Hello friends, my name is Lalit Soni and you are watching UPSC Prelims PYQ analysis series by Drishti IAS. In this episode, we will be talking about the world geography or the physical geography over here. We have already covered the one episode wherein we have discussed the Indian geography. Okay, so if you have not watched it, you can go and watch it now. It is already there in the playlist, so you can go and check out the playlist at our channel. Other than that, we will be uploading the PDF of this session at our Telegram channel, so you can go get the PDF as well. You will be finding the link of the Telegram channel in the description, so that is there. And in the end, we'll be having a mock question for you that will be can say pinned in the comment, so you can attempt that question and answer to us in the comment box. Okay, so now let's start with the second episode over here. Here we'll be discussing about the world geography, and let's start with the first section, that is Earth and the universe. Okay, so first is your question is saying that consider the following statement. Statement 1 is thickness of the troposphere at the equator is much greater than compared to the poles. So they are talking about the thickness of the troposphere at the poles and the equator. Now let's see. When we talk about, let's say this is your Earth, okay, this is your equator, these are your poles. Now if you have the idea of the insolation, you know that the maximum insolation from sun is at equator. If the insolation is maximum, that means that the heat generated or heat which is being, you can say, radiated back by the earth in the form of the long wave radiation, that will be high. That means that the temperature will be high, or the surface temperature at the equator will be high, leading to the more strong convection currents. Okay, more strong convection current means that this is your earth surface and it will be a vertical column of air, the you can say warm air. You know that warm air rises. So since the temperature of this particular surface is high and the warm air start to rise, when warm air start to rise, that is leading to the convection currents. Okay, now let's see, this is, if this is your earth and this is the height of the troposphere. Now the stronger the current, stronger will be the convection, and you will be seeing that this height of the troposphere will be pushed further to the maximum height over there. So at the equator, this height is maximum. When we talk about the poles, since the insolation is lesser over here, so the height of troposphere will be lesser because the convection currents are not very strong at the poles. Okay, so that is the logic behind it. So first, the thickness of the troposphere at the equator is much greater than the compared to the poles. So they are saying that equator thickness of the troposphere is high, so that statement is correct. Coming to the next one, at the equator heat is transported to the great heights by the strong convection currents, which we have already seen. So this statement is also correct. Now if you look at the options, option A would be your right answer, because option A is saying that the statement 1 and statement 2 both are correct, and statement 2 explains the statement 1. So we have seen that already. Okay, if you can see here, you can see the troposphere is the lowermost layer of the atmosphere. Here in this particular picture, you can see there are various layers of the atmosphere. So troposphere is the lowest layer, and here you can say average height is 0 to somewhere around 12 to 18 kilometers. Okay, so basically what we are saying over here is that the average height of the troposphere is 13 kilometers. At poles, it will be somewhere around 8 kilometers. At equator, it will be somewhere around 18 kilometers. Okay, so that is the height of troposphere. After that, you have stratosphere, then you have mesosphere, then thermosphere, and the exosphere. Respective heights are given over here. You can go through this. Respective temperatures are given over here. You can go through that. Okay. If UPSC has asked about the troposphere, there are high chances that in the next examination or somewhere they will be asking about the other spheres as well. Okay, so that is there. So here you can say average height is 13 kilometer, extend roughly to a height of 8 kilometer near the poles. So here we are saying that the poles are having lesser height than the equator, because at equator it is about 18 kilometers. I hope that is clear. Coming to the next one, thickness of the troposphere is greater at the equator because heat is transported to the greater heights by the strong convection currents. Hence statement 2 is explaining the statement 1. Here you can say in this particular picture, what they are saying is that this is your equator. Okay, and at the equator, whatever troposphere's height which is given over here in the form of A is greater than B, which is the height of the troposphere at poles. Okay, so that is the thing. Other than that, if you look at this particular picture, they are talking about the seasons, winter and the summer. Now in the summer, you will be seeing that the heat or the convection currents are way more stronger. Okay, more insolation will be there, more temperature will be there, and considering that the troposphere will be having the more height in the summers compared to the winters. Okay, so I hope that is clear. Let's move further to the next question. Now before moving further, I would like to tell you that Drishti IAS is offering IAS Prelims GS plus CSET online course. Herein we'll be having 500 plus hours of the classes. Watch time will be unlimited. When we talk about the validity of the course, in that particular validity you can watch any particular class any number of time. Okay, so that is the facility which is available, and other than that there will be 30 free tests including GS as well as CSET. The medium of instructions will be English. If you need more details, you can call us on 87501 87501, or you can get the details on the Drishti learning app, so you can download the app. Okay, now let's move further and start with the second question. Consider the following: pyroclastic debris, ash and dust, nitrogen compound and the sulfur compounds. How many of the above products are the product of the volcanic eruptions? What they are asking is that if there is a volcanic eruptions, what kind of product will be out there? Okay, so pyroclastic debris which are there, ash and the dust will be there. Nitrogen compounds, now when we talk about these nitrogen compounds, they will also be there. When we talk about the nitrogen, nitrogen will not be in the elemental form. Okay, it will be released in the form of various compounds, and then you will be seeing that with the lightning etc it will be reduced to the nitrogen. Okay, so that is also the case, that they will be having nitrogen compounds, and then sulfur compounds, they will also be there, and you will be seeing that sometimes after the volcanic eruptions there will be acid rains. Okay, that is because there will be nitrogen and as well as the sulfur compounds. Okay, so all of them, option D would be your right answer over here. Here, a volcanic hazard refer to any potentially dangerous volcanic process that put human lives and livelihood or the infrastructure at the harm. Several hazards may affect the area around the volcano as the lava will be flowing over there, pyroclastic flows will be there, landslide can happen, debris can be there. Volcanic activity also produce hazard that can affect the area far from the volcano, such as the ash falls and the tephra and the release of gases. Okay, here you can see what kind of you can say elements of the compounds are basically released over here. When we talk about the good ones over here, the source of material, when we talk about lava etc, that will form the materials over here. So here source of you can say metal, precious gems etc, that will be there, that is your lava. Coming to the next one, power generation, that can be used for the power generation, like geothermal power can be generated, or the hydroelectric power can be generated over here. Then rich volcanic soil, because of the lava, and the lava can be your you can say basaltic lava etc, so that will lead to the soil generation. When we talk about the Deccan Plateau, you know that we are having this soil, that is your black cotton soil which is there, that is also a product of your volcano only. Now coming to the next one, what are the bad part of this? So here you will be having ash, you will be having water vapor. When we talk about the release of these volcanoes, you will be having a lot amount of water vapor which will be available over there. Then carbon dioxide, sulfur dioxide, H2S, that is hydrogen sulfide. After that you will be having, you know, this particular data is not important for you. This is what you will be getting when there is a volcano. Okay, other than that, here you can see 99% of the gas molecule emitted during the volcanic eruptions are your H2O, which we have already seen, that is your water vapor, carbon dioxide, sulfur dioxide, which we have seen. Remaining 1% when we talk about, that is composed of the small amounts of the hydrogen sulfide, carbon monoxide, hydrogen chloride, hydrogen fluoride, and the other minor gases. So that can be there. If they are asking that you know, this kind of gases are coming out, obviously that gases can come out. Okay, then coming to the next one, volcanoes do not directly release a usable form of nitrogen. As I told you, elemental form of nitrogen will not be there, there will be compounds, and then because of the lightning etc, that will break into the nitrogen. Okay, so that is about this particular question. Now let's move further to the next one. On June 21 every year, which of the following latitude experience the sunlight more than 12 hours? Equator, Tropic of Cancer, Tropic of Capricorn, and the Arctic Circle. Now when we talk about the you can say 21st June, this is an important date. This is called as the summer solstice. Okay, so if you look at the Earth's position over there, you know that Earth is inclined like this. Okay, this is your equator, this is your Cancer, and this is your Capricorn. Okay, now if you have the sun over here, that particular portion is tilted over here, you will be seeing that this area will be getting the sunlight, this area over here will be getting the sunlight. Over here you can see that this is your North Pole. Okay, this is your South Pole. Since it is tilted, all the areas of North Pole will be having the sunlight. Okay, this is your, you can say Tropic of Cancer, and if you can see this is the area which is little bit tilted over here, and the South Pole will not be getting the any sunlight over there. Okay, so considering that, here you can see that the Arctic Circle over here, this is the Arctic Circle. Arctic Circle will be getting the sunlight, that is fine. Equator, when we look at equator, will be getting a little bit lesser, because obviously this is the Capricorn, sorry, this is the Tropic of Cancer, which is in front of the sun at the 21st of June, because when we talk about the 21st of June, the sun's position will be like this over here in front of the Tropic of Cancer. Okay, now considering that, equator will be little bit south of that, and the Tropic of Capricorn will also be south of that. So equator will not be there. Tropic of Capricorn will not be there, Tropic of Cancer and the Arctic circles will be there directly in front of the sun. Okay, so 2 and 4 would be right answer, that is option D. Here you can see this is the picture over here. Exactly, you can see this is your sun and this is the insolation which it is getting. This is your Tropic of Cancer. Okay, so on 21st of June, sun will be facing the Tropic of Cancer. Okay, anything above that will be getting the sunlight. So here we have the Arctic circle, here we will be having the North Pole as well. Okay, now here if you talk about the equator, equator will be little bit south and the Tropic of Capricorn will be at the south. Okay, when we talk about the 21st of June, that is your summer solstice, that is basically the largest day. Okay, so that you should remember. Other than that, other equinox are there, and when we talk about the solstice, there are two solstices. One is your 21st of June, second is your 22nd of December. When we talk about the equinox, that is 21st of March and 23rd of the September. Okay, so these are the positions, and this position will be reversed when we are talking about the winter solstice, that is your 22nd of December. Here you can see sun will be like this. This is your Tropic of Capricorn now. Okay, so that is how it is. So you can actually go through this particular picture which has been given over here, because if they have asked about 21st of June, and I'll tell you they have asked about it in 2023, 2022 and in 2024 as well. So there are high chances that they might ask you about anything from this particular picture. Okay, so here you can see this is what I have already explained over here. If you have any doubt, you can go through this. If you have doubt, you can ask me in the comment box as well. Okay, so that is there. Coming to the next one here. Next question is, in the northern hemisphere, the longest day of the year normally occurs in. See, this is the 2022 question. I told you just the longest day is 21st of June. So if you talk about this 21st of June, that will be the second half of the month of June. Option B is your right answer over here. Okay, so option B is your right answer. Same thing has been written over here, which has been explained over here as well. Okay, so you can go through this because we will be sharing the PDF. Okay, now coming to the next one here. 21st of June, the sun does not set below the horizon at the Arctic circle. This is 2019. They have asked the similar question with respect to 21st of June. Now at the 21st of June, they are saying that the sun does not set below the horizon at the Arctic circle. So here you can see in this particular picture, below the Arctic circle, they are saying that sun does not you can say sets. Okay, so that is correct, because this is the area where sun will be available. Now when we talk about the setting of the sun, that will be below this particular area. Okay, so here you can see it does not set below the horizon at the Arctic circle, because the whole North Pole is tilted toward sun over here. Here you can see this is your North Pole and it is tilted towards sun. So even in the North Pole, sun will not be setting. Okay, so here option A is your right answer. Here you can see during the summer solstice, 21st of June, the northern hemisphere witness longest day of the year, while the southern hemisphere sees the shortest day, because that is away from the sun. During this time, Earth's North Pole is at the maximum tilt toward the sun, and the sun appears directly overhead at 23.5 degree north latitude. That is basically Tropic of Cancer. As the Arctic circles fall in the northern hemisphere, the sun does not set below the horizon during the summer solstice, because here the sunrise and the sunset start to converge at the northern sky. Okay, so that is about it. Now let's move further to the next question. So the question is, with reference to the Earth's atmosphere, which one of the following statement is correct? The total amount of insolation received at the equator is roughly about 10 times that received at the pole. So now if you look at this particular statement, they are saying that the amount of insolation is basically amount of heat which is coming from sun towards the earth. Okay, so that is your insolation. Now what they are saying is that the amount of insolation received at the equator is roughly about 10 times that of the pole. So what they are saying is that the insolation which has been received at the equator is greater than insolation which is received at the pole. Now this is fine, but the problem is that they are saying that it is about 10 times. Now that is not the case. The 10 times is way too much. Okay, so that is not there. So when we talk about the heat which has been received, or the insolation which has been received at the equator, which is indeed higher than the insolation which is received at the poles, but that is not as high as the 10 times. Okay, so this statement number 1 becomes wrong. Okay, moving further, the second one, the infrared rays constitute roughly 2/3 of the insolation. Now if you look at the infrared ray, when we talk about the sun, from where when we are getting the insolations, this insolation will have different kind of you can say wavelengths which is there. So in that particular insolation, we will be having infrared as well as the visible range. Okay, now when we talk about the infrared and the visible, So if you look at the constituent, or you can say the amount that is there, infrared has the significant amount, but that is not as much as 2/3 of the insolation. So again, this is also wrong. Coming to the next one, infrared waves are largely absorbed by the water vapors that are concentrated in the lower atmosphere. When we talk about the water vapor has the capacity to absorb the infrared waves which are there. Now when we talk about the water vapor, you know that water vapor has the greenhouse gas potential. Okay, so considering that, we can say that yes, they absorb the infrared radiation. So option C can be a right answer. Coming to the last option over here, infrared waves are part of the visible spectrum of the electromagnetic waves of the solar radiation. When we talk about the solar radiations of the insolation, so there are various electromagnetic rays which are there. Among them we have infrared, we have visible range, but this infrared and visible, they are different. Okay, now when we talk about the visible one, visible you can see with your naked eyes. Now when we talk about the infrared, you cannot see them. So considering that, option D is a right wrong answer, because here you can see they are saying that it is a part of visible spectrum, but that is not the case. They are not part of the visible spectrum. So option C is your right answer. Now if you go through this particular slide over here, while it is true that the equator receives more direct sunlight compared to the poles, that we have already discussed, the actual difference in the insolation is not as large as 10 times, which we have seen. Coming to the next one, here you can say the difference between the equator and the poles primarily is due to the curvature of the earth and the inclination or the tilt of the axis which is there. We have already seen that earth is tilted like this. Okay, so that is there. Other than that, we have the curvature of the earth, because of which there is a difference which is there, but that is not very much. Okay, coming to the next one, insolation refers to the total solar radiation received at the earth's surface, which include broad spectrum of electromagnetic radiations, which we have seen, which include infrared as well as the visible light. Now while infrared radiations is the significant component of the solar radiation, it does not account for 2/3 of the insolation which we have seen. Okay, other will include the visible light, ultraviolet rays which is there, and other than that there will be other wavelengths which is present. Now water vapor, when I told you, so it is potent absorber of the infrared radiations which is there, that will lead to the greenhouse gas impact as well. Coming to the next one, if we talk about the infrared waves and the visible light, as I told you, these are two different spectrum and not a same you can say part of the electromagnetic spectrum. Okay, now coming to the next one, consider the following statement. In the first statement, it is saying that in a seismograph, P waves are recorded at earlier than the S waves. So what they are saying is that P waves on a seismograph are basically recorded earlier than the S waves. Okay, fine. This is true because P waves are faster in nature. That is fine. Seismograph is the basically an instrument which is kind of measuring the earthquakes. Okay, now coming to the next one. In P waves, the individual particles vibrate to and fro in the direction of wave propagation, whereas in the S wave, the particle vibrate up and down at the right angle to the direction of the wave. Now what they are saying is that, let's say this is your slab of the earth. Okay, now propagation of wave is like that. Okay, now when we talk about the primary wave, the wave would be like this. Okay, it is going like this, and then there will be sudden compressions, and then again expansion will be there, and then compression will be there. Now you can see the propagation of the earthquake wave is like this, and the propagation of this vibration is also in the same direction. Okay, so that is what is written over here, that the P waves, individual particle vibrate to and fro in the direction of the wave propagation. That is right. Coming to the S waves, if you look at, so S wave would be like this is your slab. Okay, after earthquake, the slab would look like something like this. Okay, so here you will be seeing that the particle over here has moved up, the particle over here has moved down. Okay, so that is basically your S waves. Okay, now here they have written that whereas in the S wave, the particle vibrate up and down at the right angle to the direction of the wave. Now direction of the wave was like that, and the particle movement is like this. So this is basically at the right angle. Okay, so both the statement are correct. Option C is your right answer. Now here you can see, here when the earthquake occurs, there are two kind of waves which are generally there, or you can say there are two specific kind of vibrations which are there. Okay, which is moving through the body of the earth from point of the fracture. Point of the fracture is basically where the earthquake has started. Okay, the primary or the P waves travel most quickly and are the first to register by the seismograph. Secondary one are the slower one, so they will be registered afterwards. P waves are also called compressional or the longitudinal waves, which we have already seen, that we have seen the compression and the expansion. So that is why they are called as the compressional or the longitudinal waves. They compress and expand the ground back and forth in the direction of the travel like the sound waves. So that is there. Coming to the S wave, we have seen that the vertical movement of the wave would be there. So that is there. Coming to the next part over here, P waves are faster, S waves are slower. P waves, the nature of motion will be longitudinal, and when we talk about the S wave, it will be transverse. When we talk about the propagation in the medium, so P waves are traveling in the solid, liquid, gas, in the all medium it will be traveling. Okay. When we talk about the S wave, they will be moving only in the solids, they will not move in the fluid. Okay. So that is the case over here. Now particle motion, that is parallel to the wave direction, and when we talk about the S wave, that is perpendicular to the wave direction. Here you can see, here this is the particle distance is very high over there, and then sudden compression will be there, and again these are at a distance, and then sudden compression is there. Okay. So that is your P waves. Coming to the S wave, here you can see this is the motion like this. Okay. So that is your S waves. Coming to the other waves, that is your love waves. These are basically, you can say, shear waves, you can say. So if there is a block like this and second block is like this, one will be moving in this direction, second will be moving in that direction. Okay. So that will be there will not be a vertical movement. Okay. Coming to the Rayleigh waves, these are rotational waves in nature. Okay. So that is about the different kind of waves which are there. I have taken the liberty to put the different seismic zones of India in this particular map. Here you can see there are 4 zones. Okay. So that is zone 5. One is zone 5, which is having the highest risk of the, you can say, earthquake. Over here, this red zone over here in the northeastern region, some part of Himalayas and the Kutch region over here. Okay. So this is the zone 5, which is having the highest sensitivity towards the earthquake. Coming to the next one, that is zone 4. Zone 4 is basically your Himalayan region, mostly you can see, and then the region which is surrounding the zone 5. Here you can say this is the zone 5 regions and it is surrounding them. Okay, so this is the area which is surrounding the zone 5. After that, you will be seeing the zone 3. This is the zone 3 which is surrounding the zone 4. Okay, so that is there the areas of Uttar Pradesh, here Delhi, Haryana, and the Punjab region, and Rajasthan, some part of Rajasthan, western Rajasthan, and these areas of West Bengal, etc. That is basically there in the zone 3. Now, other than that, we have zone 2, which is basically your central highlands and the Deccan plateau. Okay, these are zone 2. Zone 2 are least vulnerable to the, you can say, earthquakes. Earlier we used to have 5 zones, and now we have 4 zones. There is no zone 1. There is no zone 1. So please remember that. Now coming to this part over here, I have told you that the P waves will be traveling in all the, you can say, mediums. Okay, so be it liquid, gas, or solid. So here, when we talk about the earth, this is the upper part of the earth, or you can say the when we talk about the crust, and then we have the mantle. So this is the part of that which is solid in nature. So P waves are moving in the solid part as well. Then coming to the outer core, that is liquid in nature. Okay, so here also you'll be seeing that these waves are moving inside the liquid as well. But the problem is that when we are talking about this particular liquid, the reflection will be there. Okay, because of the reflection, you will be seeing that that particular wave will be reflected like this. So this area will not be getting any wave. Okay, so that is basically the shadow area of P waves. Similarly, on this side also there will be a shadow area. Okay, and then moving further to the inner core, they will be going to the inner core as well. Now here you can see this is the shadow area, that is basically your 103 degree to 150 degree, both the side. Okay, so that is there. Coming to the S waves, S waves only travel in the solid medium. So here you can say in the crust and the mantle area they will be traveling, and in the core region, which is liquid in nature, so they will not be traveling into this. So here we will be having this shadow area. This is the shadow area of the S waves. Ultimately that shadow area is from 103 degree to 103 degree. Okay, so that is basically your shadow area for the S waves. Okay, so basically we can say that the shadow area for the S wave is broader than the P waves. Okay, so that is there. Other than that, one aspect over here is that the hypocenter and the epicenter. When we talk about the hypocenter, that is the location where the earthquake is starting. Let's say this is your earth. Inside somewhere over here in the earth, there was this release of energy because of which the earthquake has started. Okay, now the projection of this on this surface will be basically your epicenter. Okay, the place where earthquake has started, that is your hypocenter. Okay, so this is something which we have discussed over here. Now when we talk about the measurement of the earthquake, so there are 2 methods over here which is given. One is Richter scale, and then Mercalli scale is there. Richter scale is measuring the magnitude, Mercalli scale will be measuring the intensity. Other than that, we have discussed the body waves, that is P wave and the S wave, surface wave, love waves, and the Rayleigh waves we have discussed. So you can go through this particular aspect over here. We'll be giving the PDF, so you can go through the PDF. You can download the PDF from the description, wherein a link of Telegram channel is given. Okay, now moving further to the next question. A major solar storm or the solar flare reaches the earth, which of the following are the possible effects on the earth? Now when we talk about the solar flare or the solar storm, these are basically nothing but the ejections from the corona of the sun. Okay, we have sun and then the outer layer is basically corona, okay, from where time to time solar winds are coming out, and these winds are coming up with the various electromagnetic radiations. Along with that, there is a matter which will be coming out. Okay, now this electromagnetic you can say elements or the matter which is coming out, or the waves which are coming out, that is interacting with the space which is there outside. Okay, so that will be interacting with the electromagnetic sphere of the earth as well. They will be interacting with the various satellites and the communication, etc. So that is there. Now wherever you will be using the electromagnetic communications, they will be interfering with that. Okay, now let's see. So what are the possible effects on the earth? First, see GPS and the navigation system. Now when we talk about the GPS and the navigation system, that means we are using the communications, that is electromagnetic communication. So it will be impacting this. Coming to the next one, tsunami could occur at the equatorial regions. Now tsunami is basically a physiological or the climatological phenomena that has nothing to do with the, you can say, solar flares, so that you can eliminate. So the second one you can eliminate from here. Second is eliminated, second is eliminated, second is eliminated. Option C is your right answer. Now if you even don't know all of that, if you can eliminate one option over here, you can go through this. Okay, now if we talk about the third one, power grid could damage. Okay, so power grid are basically your electricity related you can say infrastructure. So basically when we are talking about the electromagnetic, so that will impact the electricity as well, so this will also be damaged. Coming to the next one, intense aurora could form or occur over the much of the earth. Auroras are basically, you can say, interaction of the electromagnetic waves and the ionized particles. Okay, so considering that, there will be a different kind of color which will be emitted. That is basically your aurora. You must have heard about the northern lights, southern lights. These are basically your auroras. Okay, so that is there. So 4 is right. Coming to the next one, forest fire could take place. Again, forest fire is a phenomena which is there on earth. Now that is also related to some physical features. Okay, if there is some kind of anthropogenic activity, or otherwise there is some kind of drought like situation, so that is a physical feature and nothing to do with the electromagnetic waves. Okay, so that will also be eliminated. So if you can eliminate the fifth one, okay, so here you can eliminate the fifth one and the fifth one. So any of it, 2 or 5th, if you are eliminating any one of them, you will be reaching to the answer. Okay, so that is how elimination techniques work. Okay, so here you can go through this, which we have already discussed. Okay, when we talk about the solar storm, again here you can see sun emits large burst of energy in the form of solar flares and the coronal mass ejections. These phenomena send a stream of electric charges at the magnetic field towards the earth at a very high speed. Now they will be having some impact on the infrastructure which is there in the space or at the earth. Okay, coming to the next one. Before that, I would like to tell you that we are helping you with the prelims over here with IAS Prelims 2025 General Science course will be there. So that is a live online course which is available at the Drishti Learning app. Features are given over here. 400 plus hours of the classes will be there. Unlimited view time will be there for the time of the validity of the course, and then prelim test series will also be integrated in this particular course. Medium of instruction will be English. For more details, you can call us on 87501, or you can download the Drishti Learning app. Okay. Now we will be moving to the next section, that is basically your climatology. Okay. Now if we talk about the first question over here, which of the following is or are correct? Interference or the inferences. Okay, inference or the inferences form isothermal map in the month of the January. Now they are saying that in the month of the January, what is the map situation or the isotherm situation? Okay, now isotherms deviate to the north over the ocean and to the south over the continent. Now they are talking about the isotherm is deviating towards the north. Okay, see, this is the situation. And if you talk about this part of the, you can say this is, let's say, African region, or this is your Europe, this is your Americas, North America and South America. Now this is the Atlantic Ocean. Okay, now what they are saying is that the isotherm is deviating to the north over the ocean. Now let's see, this is the let's say this is the isotherm which is moving like this, and in the you can say ocean, it will be moving like that, and in the continent, it will be on the southern side. Okay, why is that this deflection is there? Okay, so first of all, yes, there is a deflection, so that is correct. Okay, now coming to the next one, why would there be a deflection like this? So that is simple, because in the month of January, you know that it will be, or you can say the sun will be having a overhead position at the Tropic of Cancer. So at that position, you will be getting the heat in the northern hemisphere. So in the another hemisphere, if you are getting the heat, so the water over here will start to get warm. Okay, water over here will start to get warm. Now we know that there are warm currents which are there. Okay, there are warm currents like Gulf Stream, okay, North Atlantic Drift, if these are there, so they will be moving towards the northern direction from equator towards the North Pole, okay. Now if you see that, you will be seeing that the hot water over there, that will be taken to the northwards, okay. If that is taken to the northward, that means that the hot water is moving toward the northern side, so this isotherm will also start to shift towards the northern side, okay. I hope that is clear. So that is what has been said over here in the first statement, that the isotherm deviates to the north over the ocean and to the south over the continents. So that is the one thing. Coming to the second one, the presence of the cold currents like Gulf Stream, North Atlantic Drift makes the North Atlantic Ocean colder and the isotherms bend towards the north. Now this is wrong, because when we talk about the cold ocean currents, these are not the cold ocean currents, these are the hot ocean currents, okay. So that is why statement 2 is wrong. Option A is your right answer, that is only 1, okay. Here you can see isotherms are imaginary lines that connect the points having the same temperature at the given point of time or an average over the given period, okay. These lines are used in the meteorology and the climatology to represent the temperature distribution across the geographical areas. In January, the isotherms deviate to the north over the ocean, which we have already seen, and towards south over the continents. The presence of the warm currents like Gulf Stream, North Atlantic Drift makes the northern Atlantic Ocean warmer and the isotherms bend towards the north. That is what which has happened. Over the land, the temperature decreases sharply. The isotherms bend towards the south in the Europe, okay. So that is about it. Now coming to the next question, that is, consider the following statement. Statement 1 is the rainfall is one of the reason for the weathering of the rocks, okay. Obviously that is there, rainfall is one of the you can say reason. Coming to the second one, rainfall contain the carbon dioxide in the solution. So if carbon dioxide is there in the, you can say, atmosphere, so that will be part of the rainfall as well, so that is also there. Coming to the next one, rainwater contains atmospheric oxygen. So if oxygen is there in the atmosphere, so that will contain the atmospheric oxygen as well. Now they are saying that that is the reason for weathering. How weathering will be there? If there is carbon dioxide and then there is water, they will be forming the carbonic acid, okay. They will be forming the carbonic acid. Now if we talk about the, when we talk about the, you can say, oxygen and the water over there, they will be forming another acidic conditions. Now when we talk about the acidic conditions which are there, and this acid is going over there in the or you can say on the rocks, so you can say there is this condition like acid rains which is there, okay. Or you can say if there is not there is no acid rain, just know that there is this acidic water which is there, which is forming on these falling on these rocks, and ultimately this will start to weather the rocks, okay. So that is how you can say that if there is a carbon dioxide or the oxygen in the air or in the atmosphere, they will form acidic situations and ultimately they will start to weather the rocks. So here you can see that both statement 2 and statement 3 are correct, and they are explaining the statement 1. So option A is your right answer over here. Here you can see weathering describes the general process by which the rocks are broken down at the earth's surface into sediments, clay, soil, substances dissolved in the water. Weathering can be biological, chemical, or the physical. Now right now what we are talking about is the chemical weathering. When we talk about the biological weathering, you know that there are various plants etc. are there, lichens, mosses are there, which is leading to the weathering. That is one thing. Coming to the second, physical weathering, the erosion because of the wind, because of the you can say rivers etc. That is your physical erosion, okay. Rainfall and the temperature can affect the rate in which the rocks can weather. Greater rainfall increases the rate of the chemical weathering. Rocks in the tropical region exposed to abundant rainfall and the hot temperature weather much faster than the similar rocks residing in the cold and dry region. Coming to the next one, carbon dioxide from the air is dissolved in the rainwater, making slightly acidic, okay, and ultimately that will lead to the weathering, okay. When we talk about the next one, a reaction can occur when the rainwater meets the minerals in the rock, causing weathering. Acid rain usually has pH between 4.2 to 4.4, which will lead to the acidic situations, and ultimately that will lead to the weathering, okay. Now when we talk about the oxygen, oxygen is one of the most important element collected from the falling of the rainfall. Dissolved oxygen is not the same as the oxygen in the water molecule, okay. When we talk about the water molecule, this is basically intrinsic part of the water molecule. When we talk about the dissolved oxygen, that is different, okay. So dissolved oxygen is present in all rainwater and the surface supplies due to the contact with the atmosphere. Rainwater is typically devoid of all the dissolved solid but contains dissolved gases like carbon, nitrogen, sulfur, which results in the pH that is above 5.5 again, or you can say 5.5 or lower. That means that these are creating the acidic situations, okay. So that is about the weathering and the rainfall. Coming to the next one, with reference to the water vapor, which of the following statement is or are correct? It is a gas the amount of which decreases with the altitude. Okay, now when you go in the, you can say, upper atmospheric strata, etc., you will be seeing that the amount of water vapor is declining. So that is one fact which is there. Okay, coming to the next one, its percentage is maximum at the poles. Okay, now this is wrong. Now, because simple reason is that this is your earth, this is your sun. At the equator you will be having the more insolation. Because of the more insolation, more water will start to get vaporized. Okay, so that is there. If you go toward the pole, there is lesser insolation, so lesser water will be evaporating, or you can say the conditions over here in the pole are such that the water is there in the ice form. Okay, so there will not be evaporation, so water vapor will not be very much present in the pole regions. Okay, so that is there. At the equator it will be higher, at the pole it will be nearly, zero. Okay, so you can say not zero, it will be like 2 or 3%, that will be there. But the thing is, it is not maximum at the pole, it is maximum at the equator. So option A is your right answer, only one. Okay, water vapor is water in the gaseous form. The earth is the most abundant greenhouse gas. When we talk about the water vapor, as I told you, this is a greenhouse gas, or it is having a potential of global warming, etc. The troposphere contains 99% of the water vapor in the atmosphere. Water vapor can contain decreases rapidly with the altitude. Now when we talk about the first or second question which we have discussed, where we have discussed about the troposphere, mesosphere, stratosphere, etc., so you will be seeing that in the upper strata you will not be getting water vapor. Okay, so water vapor concentration vary with the latitude position as well. North to south it will vary. Why it is there, I have already told you. So when we talk about the concentration of the water vapor at the pole, so that is basically they are greatest above the tropic, where they might be as high as 3% and decrease towards the polar regions. So here you can see, sorry, I would have told you that it will be around 3%. It is at equator that would be around 3%, and at the poles that will be decreasing around to the 0. Okay, so that is there, decreases toward the poles in the region. Now coming to the next one, consider the following description. Annual and the daily range of temperature is low. Precipitation occurs throughout the year. Precipitation varies between 50 to 250 centimeters. Now here you can say daily and the annual range of temperature is low. Okay, now when we talk about the here 4 climatic situations are given. One is equatorial, China type, humid subtropical, and the marine west coast climate. Okay, now they are talking about a particular kind of climate wherein they are saying that the annual and the daily range of temperature is low. That means that there is a moderating effect which is there. Moderating effect wherever it is there, that means that it is a Mediterranean kind of climate, or this is marine west coast climate which is there. Okay, so option D is your right answer over here. Now my suggestion to you would be that you should go and check out all these 4 climatic conditions, because in 2024 they have asked about it. There are high chances they might ask about one of them in the next examination. So that is there. Coming to the next one, marine west coast climate condition. It is observed poleward from the Mediterranean climate. Okay, as I told you, Mediterranean climate, it can be there on the west coast of the continents. Okay, so if you go toward the polewards and on the west coast of the continents, this will be observed over there. Mean temperature in the summer months range from 15 to 20 degrees Celsius. In the winters, that is 4 to 10 degrees Celsius. The annual and the daily ranges of the temperature are small. Precipitation over here, that is 50 to 250 centimeters. Okay, due to the marine influence, the temperature is moderated, and in the winters it is warmer than the latitudes. Okay, so basically what they are saying is that in the winter it will be little bit warmer, in the summer the temperature will be managed because of the moderating effect of the sea. Okay, so that is the reason behind that. That is your Mediterranean climate or the marine west coast climate. These are the reasons. They have said that you can say polewards on the west coast of the continent. Here you can say this is the west coast of the continent, this is the west coast of the continent, this is the west coast of the continent. Okay, again in the Madagascar region you can say that it is also present over there. Okay, so that is about it. Here you can say these are the main areas: northwestern Europe, west coast of the North America, north of California, this is over here, then southern Chile, that is somewhere over here in the South America, southeast Australia, and the New Zealand. Now this is something which you should remember, the New Zealand and the Madagascar. Why? Because throughout over here you will be seeing that there is the moderating effect of the sea. Okay, so that is about it. Now let's move further to the next one. Consider the following statement. First is high cloud primarily reflect solar radiations and the cool the surface of the earth. Okay, they are talking about the high clouds which are primarily reflecting the solar radiation. Now that is not the case. When we talk about the clouds, the low clouds, they will be low, and when we talk about the thick clouds, they will be reflecting the solar radiations. Okay, so that is there. Coming to the next one, the low clouds have the high absorption of the infrared radiation emanating from the Earth's surface. Now that is also wrong because they have interchanged it. So basically this is the, you can say, high clouds have the high absorption of the infrared radiations. So that is there. So that when we talk about the correct option over here, so option D would be a right answer. Okay, so that is about it. Here you can see the study of the cloud. When we talk about the where cloud has been formed or what are the conditions like that, so these characteristics or these studies of the cloud will help you understand the climate change, okay, or the other weather phenomena. Low thick cloud primarily reflect the incoming short wave solar radiations and cool the surface of the earth. How? Because when we talk about the, this is your earth, this is the low cloud formation which is there. So whatever sunlight is coming over here, that will be reflected back. Okay, when it is reflected back, that the temperature of the earth will not rise. Okay, it will not rise. Now on the other hand, when we talk about the long wave radiations, which are emanated from the earth, okay, after earth gets the insolation, it will be emanating, or you can say radiating back the long wave radiations. Now when these long wave radiations are going outside, so at the higher latitude, what will happen is that these thin clouds are there, which is basically not letting it pass. They are absorbing these particular you can say long wave radiations, and ultimately because of which the temperature of the earth will be rising. Okay, so that will have a greenhouse gas like effect. Okay, now here just know that when we talk about the low and the thick clouds, these are primarily reflecting the, you can say whatever insolation is coming from the sun. And the next is high thin clouds primarily transmitting incoming solar radiations. At the same time, they trap the some of the outgoing long wave infrared radiations. So these long wave radiations, these are basically which are emitted from the earth. Okay, and when we talk about the short wave, these are coming from the sun. So basically the high and the thin clouds, what they do is that they let the insolation from the sun, or the short wave insolation which is coming from the sun, they let it enter into the earth. But when we talk about this, these long wave radiations which are emitting from the earth, they have actually trapped it in the, you can say, earth atmosphere, because of which what happens is that the temperature will start to rise. Okay, so that is about it. Moving further to the next question, in the context of which of the following do some scientists suggest the use of the cirrus cloud thinning technique and the injection of the sulfate aerosol into the stratosphere? Stratosphere they are talking about. Okay, that is means that high clouds. Okay, the high clouds, which means that they are the one which are responsible for the greenhouse gas. Okay, they are the one which is trapping the long wave radiations. Okay, so that is there. So what they are saying is that they are going for the thinning of the cirrus cloud. Okay, so basically if you want to reduce the thickness of the clouds over here, so what you have to do is that you are injecting the sulfate aerosol. Now why would you do that? You are trying to make sure that these long wave radiations are not trapped, so that the greenhouse gas effect does not take place, or the, you can say, the global warming does not take place. Okay, so the reason over here is that option D, reducing the global warming. Okay, simple terms we have already seen over here, that the high and the thin clouds, high clouds will be there in the stratosphere, because the bottommost layer of the atmosphere is troposphere. So in the troposphere you will be having the low clouds, in the stratosphere you will be having the high clouds. So these high clouds are basically trapping the long wave radiations which are going from the earth towards the outside. Okay, they are trapping it, because of which the temperature is increasing. That means that they are increasing the global warming. Now the idea here is to stop that. So here reducing the global warming by using this nucleus like sulfate aerosol etc., so that you can go for the thinning of these clouds. Okay, so that is about it. Here the cirrus cloud thinning is a kind of technology that involves thinning the wispy and the elongated cirrus cloud of the high altitude. Cirrus cloud do not reflect a lot of solar radiations back into the space, but as these are formed at the high altitude and the cold temperature, these could trap the long wave radiations coming from the earth, and by injecting the ice nuclei such as the we have already seen the sulfate aerosol etc., they will be going for the thinning of the cloud, that would allow more heat to escape into the space. Okay, so that is about it. Now moving further, why are dewdrops not formed on the cloudy night? Dewdrops are not formed on the cloudy night. Now when we talk about the dewdrop, what is there? generally you must have seen that in the early morning, you must have seen that on the plants or on the earth surface, you will be finding the droplets of water. Okay, these are dew drops. Okay, why these are actually formed? Because as I told you, there are some of the radiations which will be actually emitted from the earth surface. Okay, now when the earth is emitting the long wave radiations, when this is emitted, so the surface of the earth will start to cool down, because it has actually left the long wave radiations. Now it will start to cool down. When the temperature reaches to a level where it will start to go for the more and more cooling effect, so ultimately in the vicinity of that, if there is a plant, if there is a, you can say, let's say a car which is there, so on the surface of that you will be seeing that there will be droplets of water. Okay, so these are called as the dew drops. So here you can see they are saying that if there is a cloudy night, that means that the long wave radiations are not able to get out of the earth's atmosphere because of the heat trapping. As I told you, they will be going for the trapping, clouds will be going for the trapping, because of which these, you can say, temperature will be high, temperature will not go below a particular level, so dew drops will not form. Okay, why are dew drops not formed on the cloudy night? Cloud absorbs the radiation, you can say, released from the earth's surface. They are not absorbing it, they are sending it back to the earth. Okay, so cloud reflect the radiations back to the earth, and because of which the temperature will be high, and ultimately you can say dew drops will not be formed. Over here you can see dew is a type of precipitation where water droplets form on the ground or the object near on the ground in the process of the condensation of the moisture. Favorable condition when we talk about, so that is basically clear sky, light wind, decent soil moisture, low night dew drop depressions, that is there. Dew forms when the temperature becomes equal to the dew point, i.e. that is basically the atmospheric temperature below which the water droplet begin to condense. As a result of the condensation, you will be having the dew formation. Okay, now long wave emissions, if there is a cloudy night, these emissions will not go outside the, you can say, these cloud formats, and ultimately the temperature will be high, temperature will not go below the dew point, and ultimately you will be seeing that there is no dew. Okay, so that is about it. Now consider the following statement: in the tropical zone, western section of the oceans are warmer than the eastern sections owing to the influence of the trade winds. Okay, so we will be seeing, coming to the next one, in the temperate zones, westerlies make the eastern section of the ocean warmer than the western sections. Now here they are talking about basically the winds. Okay, so here you know that this is your equator, and then over here we will be having the trade winds, and then we will be having the, you can say, westerlies, etc. Now if there is a picture over here, okay fine, there is a picture here, you can see these are your equator, and then we are having the trade winds over here. Okay, now trade winds has this tendency that they will be taking this water towards this direction. Okay, so that is there. So whatever statement is there, in the tropical zone, the western section of the oceans are warmer than the eastern sections. Okay, so let's see, this is your western section, this is your eastern section. Why is that the western section is warmer? Because these are the, direction of the winds. All the winds are going towards the western section. So basically whatever water is there, that is the warm water, because it is the equator. So this is the warm water, and this is moving towards the west direction. So you will be seeing that the western section at the equator are warmer. Why is that this is the warm water? Because obviously this is the equator where insolation is high. Okay, so that is there. Considering that, the statement 1 becomes right. Coming to the second one, in the temperate zone, westerlies make the eastern section of the ocean warmer. Here this is the temperate zone, this is the tropical zone, this is basically your temperate zone. Now what they are saying is that the westerlies are making the eastern section warmer. This is your eastern section, this is western, and here you can see, here also you will be having the westerlies, this is also a temperate zone. So here eastern section will be warmer, because the, you can say, winds are taking the water towards this direction. Okay, and why is that? Because the water is coming from the, you can say, equator side and going towards the pole. So this will be the hot water or the warm water. So this warm water will be moving towards the eastern section of the, you can say, globe over there. So option C would be your right answer, because both the statement are correct. Okay, option C is your right answer. Same thing has been written over here, you can go through it. Okay, now consider the following statement: jet streams occur in the northern hemisphere only. Only some cyclones develop an eye. The temperature inside the eye of the cyclone is nearly 10 degrees lesser than that of the surrounding. Now let's see the first statement: jet streams only occur in the northern hemisphere only. Now that does not make sense. Most of the time you will be seeing that when you go for the any kind of climatic phenomena or the weather phenomena, you will be seeing that both the, you can say, hemisphere are having it, be it in a different ratio, but it will be there. So that statement is wrong. Jet stream is a phenomena of both the you can say places in the temperate zones. Okay, coming to the next one, only some cyclone develop an eye. Now when we talk about eye, you know that there are two kind of cyclones. One is your tropical cyclone, one is temperate cyclone. When we talk about the tropical cyclones, that will be having an eye. Okay, temperate cyclone does not have the feature like eye. So only some cyclones develop an eye. So this is perfect. Coming to the next one, the temperature inside the eye of the cyclone is nearly 10 degrees lesser than that of the surroundings. Now that is wrong, because when we talk about a cyclone, you know that there is a low pressure system, and then there is a low pressure system, and the temperature is high, that is nearly around 27 degrees Celsius. So there will be a convection. There will be a convection, and the hot air will start to rise over here, and then because of the Coriolis force, they will be generating a curvature over here, and this is how the cyclone will be developing. But the thing is, in the center part of it, where the convection is happening, okay, so temperature is already high, hot air is moving in the vertical column over there, so this area will be having a temperature which is higher than that of the rest of the cyclone. So over here you will be seeing condensation, precipitation will be there, so because of which the temperature will be lesser. Okay, but in the eye, because of the convection, so temperature will be higher over here and not less. So considering that, option this statement 3 will be wrong. So only one is correct over, only 2 is correct over here. Option C is your right answer. Okay, so I hope that is clear. So let's see, option C is your right answer. Jet stream is a geostrophic wind blowing horizontally through the upper layer of the troposphere, generally from the west to east. Now here I will tell you what is jet stream. Okay, so see, this is the globe. We are having surface winds, like we have seen the trade winds will be there, easterlies, westerlies will be there. Okay, so these are on the surface, ocean surface. Now on the where we go over the, you can say, upper atmosphere. So in the upper atmosphere also there is a wind circulation which will be there. Mostly it is from the west to east. Okay, here you can see this is from the west to east. Okay, that is one thing. That is because of the rotation of the earth. Okay, now this is there. These are called as the jet streams. In the upper atmosphere, whatever horizontal movement of the air is there, that is called as the jet streams. Okay, now if you can see this, you must have heard about the Ferrel cell and all these cells are which is there. So if there is a cell, these are the cell. Okay, these are the cell which is there. The convection, when we talk about the low pressure, there will be convection, air will be rising, and then over here air will be moving in this direction, and then it will be actually you can say descending in this particular area of high temperature, high pressure. Okay, so that is there. This is how these cells will be formed over here. Now these are generating the surface level wind phenomena, surface level currents. Okay, that is there. But now when we talk about this particular place over here, there is a concentration of these winds, and you will be seeing that these winds will be moving in the horizontal direction over here. These horizontal direction, these are called as the jet streams. Okay, now there is polar jet stream, there is a subtropical jet stream. In the tropical area we do not have jet stream. Okay, so here you can see that will be over here, and in the southern hemisphere also that will be the same phenomena, because these cell will be there in the southern hemisphere as well. Okay, so considering that, these are your jet streams, and these are curvy in nature, meandering in nature. Okay, so that is there. So that is your jet stream. So here you can say jet stream develop where the air masses of the different temperature meets. Air mass of different temperature is meeting over here. So usually surface temperature determines where the jet stream will form. Okay, why? Because the surface temperature, this will be going above. Okay, and now here you can see these are the hot winds which are rising, and then here you can see these becomes cold. So that is why there is a temperature difference, because of which there will be a jet stream which will be forming over here. That is one thing. Second thing is, if the temperature is very high, the convection will be very fast. If the convection is very fast, so here you will be seeing the temperature difference will be very high, and if the temperature difference is high, that means that the speed at which the jet stream will be forming or the moving, that will be high. Okay, so that is given over here. Greater the difference in the temperature, faster is the wind velocity inside the jet stream. Jet stream extend from 20-degree latitude to the poles in both hemisphere. Okay, 20-degree latitude to the poles in both hemispheres. So that is about jet streams. Coming to the next part of the cyclone and the eye, here you can see this is the eye of the cyclone. Here convection will happen. These are the area. This is your eye wall. Okay, and now here you will be seeing that the condensation will be there, and ultimately precipitation will be there over here, because there are various clouds will be formed over here, and this is the movement of the cyclone here. When we talk about this is the movement over here, that is because of the Coriolis force. So that is a typical, you can say, tropical cyclone in which there is a feature of eye. Okay, and this eye temperature will be higher than the temperature of the eye wall and the other part of the cyclone. So that is there. Here you can see condition for forming of the you can say your cyclone is there, that is more than 27 degrees should be the temperature, Coriolis force will be there, there should be a vertical wind speed which is high, okay, and then a pre-existing weak low pressure area should be there, low pressure area plus high temperature, that is how you will be forming the you can say cyclone. There are different names of the cyclones which are given over here in the different regions. Cyclones are named with different types, okay. So here's typhoon, that is Southeast Asia and the China. Hurricanes are there in the North Atlantic region, and the tornado which are there in the Africa and the southern USA. Willy is called they are called in the northwestern Australia, and tropical cyclones, that is in the southwest Pacific and the Indian Ocean, okay. So that is about the cyclone. Over here you can see there is one thing which is here. However, in the temperate cyclone there is not a single place where the winds and the rains are inactive. So in the temperate cyclone, throughout the you can say cyclone, there will be winds, there will be rains. So that is why the phenomena of eye does not exist over there. Now when we talk about the tropical cyclone, you will be having the eye over there. So in that particular area there will not be rain, that will be only for the convection, okay. So that is there. Coming to the next part, before that I would like to tell you that we are having IAS prelims test series for 2025. When we talk about the practice, we are going for the PYQs, that is giving you an idea that how UPSC is asking questions, but we have to go for the practice as well. There are certain areas which we have to revise from the static part as well. So for that, test series becomes important. So we are having various packages which are available on the Drishti learning app. So you can download the app or you can call us on 87501 87501. In the test series, you will be having the comprehensive coverage of the syllabus, subject wise evaluation will be there, and the detailed explanation will be attached with the test, okay. So that is about it. Now let's move to the next one, that is resources of the world, okay. Over here we will be talking about some of the questions over here. Consider the following statement. Recently, Venezuela has achieved a rapid recovery from the economic crisis and succeeded in preventing the people from fleeing, immigrating to the other countries. Now that is a situation of the current affairs which was there in 2024, but again right now also Venezuela has not achieved a rapid recovery, so still there is an economic crisis which is going on in the Venezuela. Venezuela has world's largest oil reserves. So if we talk about in this particular statement, so that can be true, but the statement 1 is false, okay. So option D is your right answer. The statement 1 is incorrect and statement 2 is correct, okay. So here you can go through this explanation, that is not needed because Venezuela is still going through the you can say economic crisis. Moving further to the next one, which of the following countries are well known as the two largest cocoa producers in the world? So answer is option C, Cote d'Ivoire and the Ghana. These are the areas which is producing the largest cocoa. This is something factual question which you can't do anything about it. But the thing is, what they are giving you an idea that they are asking about the cocoa production. Next time they can ask you about the exports, okay. So that is there. Otherwise they can ask you about the coffee, they can ask you about the tea. All these things can be there. So these are the region which is producing cocoa. Here you can say Cote d'Ivoire, which is basically 45.2% of the whole production, and then here Ghana is responsible for the 17.6. When we talk about India, these producers are there: Andhra Pradesh, Kerala, Tamil Nadu, Karnataka, and Telangana. When we talk about the other areas where cocoa is produced, so this is African region over there, and then when we talk about the Brazilian region over here, Ecuador, Indonesia, and the archipelago. So basically here we have cocoa productions. Now moving further. You can go through this particular explanation. We have already seen that these are the two countries which is accounting for nearly 60% of the global production, and here you can see Ghana is another top producer of the cocoa. Then coming to the Western Africa, hosts the world's leading cocoa producing countries which is there, and then in the end in Asia, Indonesia is the largest producer, which we have already seen. About 3/4 of the world's cobalt, a metal required for the manufacturing of the batteries for the electric motor vehicle, is produced by Argentina, Botswana, Democratic Republic of Congo, and Kazakhstan. So option C is your right answer, that is Democratic Republic of Congo. So again here you can see they are asking about cobalt, they are asking about cocoa, they are asking about the things which are quite crucial, okay. So that is there. You can go through this over here. Then moving further, with reference to the water on the planet Earth, consider the following statement. The amount of water in the rivers and the lakes is more than the amount of groundwater. Now that is wrong, okay. So because groundwater is higher over there. The amount of water in the polar ice caps and the glacier is more than the amount of groundwater. Now that is perfect, okay. So here you can say ice caps are having more water, okay, and then you can see that the groundwater is the one. Then you have the surface water, okay. So that is there. Here in this option B would be your right answer. Okay, here you can see this is the whole water when we talk about. So here nearly 96.5% water is there in the ocean. Then here you can say there is this other saline water which is there 0.9%, and fresh water is somewhere around 2.5%. Among the fresh water, here you will be having the maximum water is there in the glaciers, that is 68.7%, and then here you can see that is 30.1%, which is groundwater, and the remaining water 1.2%, that is your surface water, that is rivers, lakes, etc. Okay. Out of the surface water, you will be seeing that the ground ice and the permafrost, which is having responsible for the 69.0%, and then we are having lakes. Then you will be seeing that in the soil, etc. you will be having. So that is how you can see the composition of the water in the earth. So moving further, nearly 71% of the earth's surface is water covered, which you can go through, and same things which we have covered over here has been written over here in the text, so you can go through this. Now moving further, with reference to the palm oil, consider the following statement. The palm oil is native to Southeast Asia. Now this is not native to Southeast Asia, it is native to Africa. Okay, so that is one thing. Statement 1 is wrong. If you remember the statement 1 over here, so option B is your right answer, that is 2 and 3. The palm oil is a raw material for some industries producing the lipstick and the perfume, that is fine. And the palm oil can be used for the producing the biodiesel. If there is something which has been generated by the cropping or the forestry, so that can have the potential to be a biofuel. Okay, so that is there. 2 and 3 is your right answer, option B. Okay, so you can go through this. I have attached some of the specific things over here. The palm oil is an edible vegetable oil. India is an importer of the palm oil over here. It is native to Africa, but later on you have seen that other countries are also now, you can say, they are basically growing it. Tree grows best in the tropical climates. Here we have given the condition, climatic condition, humid tropical condition. Humidity is required, that is 80%. 250 to 400 centimeter rainfall is required. Temperature is 22 degrees to 24 degree minimum, and 20 degree to 33 degree maximum. Sunshine is given, and the soil that is thriving in the well drained, fertile, loamy soil. Okay, so that is the conditions. When we talk about the maximum producers over here, you can say 90% of the world's palm oil is basically produced in Malaysia and Indonesia. Okay, so here when we talk about India, India is the largest global importer of and the consumer of the palm oil. Top producers in India are Andhra Pradesh, Telangana, Kerala. That is 98% of the palm oil is coming from over here. Okay, growing extensively in the native West and the Central Africa, also grown in the Asia, Africa, and the Latin America, which we have seen. When we talk about the other oils, so when we talk about India, palm oil is the maximum import, and then we are importing the soya bean as well, then sunflower as well. Now palm oil is being imported from the Indonesia and Malaysia because these are the largest producers. When we talk about the soya bean, we are going for the Brazil and Argentina. For the sunflower, we are taking it from Russia, Turkey, and Romania. Okay, so that is something which you should remember. Coming to the next one, which one of the following group of the plants was domesticated in the New World and introduced to the Old World? Okay, now the New World is basically the one which has been discovered after the Christopher Columbus discovery of America. Okay, so Americas are considered as the new one, and the Asia and the Europe, these are considered as the, you can say, old world. Okay, so that is old world versus new world. Now when we talk about the old world, you know that if you go through the options over here, tobacco, cocoa, and rubber. One thing, let's hold for a second. Tobacco, cotton, and rubber. Now if you see the cotton, discovery of Americas is somewhere around in the 15th century or something like that. Okay, 15th century. So if it is there in the 15th century, so before that we have seen that in the Indus Valley civilization we had the cotton, so this is gone. Okay, so if you find cotton anywhere, that is a particular, you can say, can be eliminated. Wheat was also there in India, so we can eliminate that. So option A is your right answer, that is tobacco, cocoa, and rubber. So we have already seen what is your you can say old world and then new world. Tobacco is a crop which is from the America, okay, South American continent, so this is from the new world. When we talk about the natural rubber, that is also from the South America, so that is also from the new world. Cocoa is also from the Amazon basin, that is basically your Southern America, so that is also new world. Okay, cotton and the wheat, they were found in the Indus Valley civilization, so we can say that that is from the old world. I have taken the list over here. These are the plants of the new world, these are the plants of the old world. You can go through this, okay, or you can take the screenshot. Okay, now let's move further. ISGS Foundation course we are providing. Key features are 1000+ hours of the classes, unlimited view time, and the prelims test series will be included in that. Medium of instruction will be your English medium over here. For more details, you can call us on 87501, or you can download the Drishti Learning app. This is a live online course, so you can take the help of the app over here. Now, with that, we will be finishing this session. We will be coming up with one more episode of geography, in which we will be discussing about the various regions of the world. So in that we will be going through the PYQs of various regions. Okay. With that, I would like to take your leave. There is a question in the comment box. You can go and answer that particular question. Okay. With that, have a nice day. Thank you, and please subscribe the channel.
For more informative content, like, share and subscribe, and do not forget to press the bell icon to get the notifications.